All right, so what we're going to be looking at now is that we're going to be looking at our last part about the normal distribution and that normal curve and the normal approximation. And we're going to be focusing on something called the honest and dishonest coin principles. And from here, we're going to go into a little bit towards the end about standard or confidence interval and basing off that. Okay. Now, first things first. Let's say you make a bet. So, Mr. Lincoln comes into the room and goes, "Hey, I got a bet for you." And you go, "Okay, okay, I'm going to listen to you, Mr. Lincoln, because you were great for America." And he comes in and he goes, "Okay, I'm going to roll this die. Standard six-sided die that we all have, we've all used. Nothing funny with it, and we're trusting it because it's Abe Lincoln. I mean, you don't mess with Abe Lincoln." And so you're going to roll this die 356 times. Now, the bet that he tells you is that, when I roll this 356 times, it's going to come up heads, not heads, not a coin. It's going to come up even. It's going to come up even between 168 and 188 times when you roll this. And you've got to think, is this a good bet? Or is Mr. Lincoln trying to play me as a fool? And then you're going to go, "Okay, I know how to do this. It's math!" Because math can do everything, and math can solve all the world's problems. And so what we're going to do here is that first we want to find out what's the average. So if I were to roll a die, 356 times, on average, how many times will it come up even? Well, it's 50-50. You can either have it can either be heads or it can either be odds. And so when we roll it, we're just going to go 356 and divide it in half. And that gets us approximately 178. And that is our mu, or our average. So in our normal our curve, 178 will be right about there. Okay. After that, we want to look at our our standard deviation. And to find our standard deviation, or our sigma, what we're going to do is we're going to take the square root of the number of rolls and divide it by 2. Now when we do this, it should be approximately, we get approximately 9.43. And I'm going to round that up, okay, just as a safe bet. So we're going to round that up to 10. So that means we're going to say our sigma is 10 and our mu is 178. Now if we look on both sides, let's go to the next slide. Now if that's our case, if we look on both sides of this, and we're going to take our standard deviation to both sides. So we're going to subtract it and add it to that mean. We get about 168 and 188. And that's the range that Mr. Lincoln has given us. And we're going to go, okay, if that's the case, how many times will it fall within that range? How many times would it fall within that range? And then you go, I got it. I remember from what I learned a little bit ago, which is the empirical rule. If you're one deviation on both sides, approximately 68% of the data will fall within that range. 68% of the data will fall, 68% of the time, when you roll that die 356 times, it will fall within 168 and 188 times it will be even. And you go, 68% of the time I win? I think I'm going to take that bet, Mr. Lincoln. He goes, shucks, you got me. I thought I could play you for the fool and make you not take this bet. But we did, and we end up winning because we're awesome and we're good at math. Now, after Mr. Lincoln walks away, you give him a high five and go, yeah, good job, Mr. Lincoln. After that, Stalin comes up. He's got that evil stare. And you're just like, okay, Stalin, what do you want? Now, when Stalin comes up to you, he goes, okay, I got a bet for you. I've got this die. He throws a die on the coin. He throws this coin on the table. And you're like, man, you're kind of an angry person. He's like, yes, I am. And you're like, okay, whatever. What's your bet? Now, his bet is basically, if he flips this coin 648 times, he wants to make the same type of bet with you. 311 to 337 times, it will be heads. Now, doing a quick calculation like what we did previously, we would find that this actually falls within one deviation of the mean. So we would have a 68% chance of winning. But do you trust Stalin? That is the key question. Or does he have a loaded coin? Ooh. So the first thing you want to do is say, wait a second here. I want to test out this coin because I don't trust you like I trust Lincoln. I mean, Lincoln was our 16th president. So I trust him, but I don't trust you, Stalin. And so what you're going to do is that you'd want to test it out. Now let's say we flip this coin several times. Let's say 100 times. And you see that it only comes up heads only about 25% of the time, So it's not giving you a great read that it's an even coin. Basically, it's saying that no, it is weighted to one side. It's going to be tails more often. So Stalin's trying to play you, and you go, silly Stalin. Yeah, you didn't get me. I'm smarter than the average person. And now Stalin goes, okay. So what we find is that if we had 25% of the time, we're going to label that as our P. Okay. So it's going to be about, our P is going to be about 25. Or since it's not even, it's not 50-50, we're going to have to change that. We're going to have to shift it to one side. In which, if it was 50-50, our P would be 0.5. But since it's not, we would say it's 0.25, and then move on. So now that we have that as our P, our 0.25, 25% of the time we win, now we want to find out, okay, well, if we want to do the same standard deviations, what should we do? Now the first thing to do is find what's your mean. What is the average? Well, to find the average number, if you win a quarter of the time, you would take the number of flips and multiply it by the percentage of winning. And that comes up to be approximately 162. So on average, if you were to flip this coin 648 times, you win 162 times. And you go, okay, that's where it's probably going to come up. So yeah, Stalin, I'm not even going to take your bet. I mean, that's just a silly one. So now we go, okay, what's our standard deviation? Well, standard deviation is kind of the same as the previous one, but it's not simplified. The one we used previously was simplified. This is the more expanded version. And basically, it's the square root of n times p times 1 minus p. So it's the number of flips times the probability of us winning times the probability of us losing. So if we plug in our numbers, it would be the square root of 648 times 0.25 times 0.75. And we simplify that down and we get our sigma approximately 11. It's a little over, it's like 11.02, but we still have our number. So it's approximately 11. Now if we do our standard deviation on both sides, we see that we have about 151 to about 173. And we go, Stalin, if you want to give me those, then I will take this bet. But he goes, no, this is not how this works. I choose what it is, and if you don't want it, then too bad. And you go, okay, well, I'm not going to make this bet. And then he storms off, angry, angry, angry. Well, now, what we found here is that 68%. This is called, in statistics, the confidence interval. We are now 68% sure that if we were to flip this coin 648 times, it would fall within this range. Okay? We are 68% sure. That's one deviation on both sides. Now, if you want to take two deviations, so if we take another deviation to both sides, which will put us down to 140 and up to 184, that gives us a 95% chance of falling within that data. And now we're 95% sure that it's going to fall within this range. And then finally, if we do three deviations, which will put us at 129 up to 195, that gives us our 99.7 from our empirical rule that we learned previously. This is called our confidence intervals, or CIs. Now this is used for seeing if something is being produced and it's falling into the range that you want. You can do it for a certain percentage. And you can say, I'm 95% sure that it works. I'm 99.7% sure that it's in this range. Or, no, it doesn't fall in this range, and I'm 95% sure that it doesn't. And these are used in like hypothesis testing, other branches of statistics, which is a very interesting topic for another time.